Welcome friends in the video NCERT Chapter 8 Introduction to Trigonometry Class 10 Part 3. In the previous video, we have learned that in a right angle triangle, hypotenuse is the side opposite to the right angle. Perpendicular and base depend on the angle which we consider as theta. Perpendicular is the side opposite to theta. Base is the side adjacent to theta. We also came to know about the values of trigonometric ratios of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, and also about the trigonometric ratios of complementary angles. In this video, we are going to learn about trigonometric identities. We all know that an equation is an identity when it is true for all values of the variables involved. Similarly, an equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angles involved. Here, if you consider this right angle triangle ABC, where angle B is the right angle and angle A is the theta, then we have AB as the base, BC as the perpendicular and AC as the hypotenuse. Now, in this triangle, by applying Pythagoras Theorem, we have AB square plus BC square is equal to AC square. Let it be equation 1. Then, if we divide each term of equation 1 by AC square, we get AB square by AC square plus BC square by AC square is equal to AC square by AC square. That is, AB by AC whole square plus BC by AC whole square, which is equal to 1. Now if you see here carefully, you will observe that AB by AC is base by hypotenuse, that is cos A, and BC by AC is perpendicular by hypotenuse, that is sin A. Therefore, we have cos A whole square plus sin A whole square is equal to 1, that is cos square A plus sin square A is equal to 1. Let it be equation 2. Here, if A is equal to 0 degree, then we know that cos 0 degree is equal to 1 and sin 0 degree is equal to 0. Therefore, the sum of the squares will be equal to 1. Similarly, if A is equal to 90 degree, therefore sin 90 degree is equal to 1 and cos 90 degree is equal to 0. Therefore, sum of their squares will be equal to 1. From this, we can say that this identity is true for all values of A such that A is greater than or equal to 0 and smaller than or equal to 90 degree. Let us take one more example. We have cos square A plus sin square A is equal to 1. Here, if angle A or theta is equal to 45 degree and we know that cos 45 and sin 45 both are equal to 1 by root 2, then cos square 45 plus sin square 45 will be equal to 1 by root 2 whole square plus 1 by root 2 whole square, which is equal to half plus half, which gives 1, hence proved. Let us now see how many more equations can we make from this equation. Equation 1. Sin square A is equal to 1 minus cos square A. Second, cos square A is equal to 1 minus sin square A. Third, sin A is equal to root over 1 minus cos square A. And fourth, cos A is equal to root over 1 minus sin square A. Now if you look here again, then by applying Pythagoras theorem, we already have AB square plus BC square is equal to AC square, which is equation 1. Then if this time we divide this equation by AB square, we get AB square by AB square plus BC square by AB square, which is equal to AC square by AB square, or 1 plus BC by AB whole square is equal to AC by AB whole square. Observe here that BC by AB is perpendicular by base, that is tan A, and AC by AB is hypotenuse by base, which is sec A. Therefore, we have 1 plus tan A whole square is equal to sec A whole square. That is 1 plus tan square A is equal to sec square A. Let it be equation 3. Now note here that this equation is true when A is equal to 0 degree. But when A is equal to 90 degree, then we know that tan 90 and sec 90 are both not defined. Therefore, this equation is true for all values of A such that A is greater than or equal to 0 degree but less than 90 degree. Now let us see how many more equations can we make from this equation. Equation 1. Sec square A minus 1 is equal to tan square A. Equation 2. Sec square A minus tan square A is equal to 1. Equation 3. Sec A is equal to root over 1 plus tan square A. And 4th, tan A is equal to root over sec square A minus 1. We also know that tan A is equal to sin A by cos A and sec A is equal to 1 by cos A. Now try to write this identity in terms of sin A and cos A yourself. Now here, if we divide equation 1 by BC square this time, we get AB square by BC square plus BC square by BC square is equal to AC square by BC square. That is, AB by BC whole square plus 1 is equal to AC by BC whole square. Again, observe here that AB by BC is base by perpendicular and AC by BC is hypotenuse by perpendicular. Then we have cot A whole square plus 1 is equal to cosec A whole square, or 1 plus cot square A is equal to cosec square A. Let it be equation 4. Note that cosec A and cot A are not defined for A is equal to 0 degree. Therefore, equation 4 is true for all A such that A is greater than 0 degree and less than or equal to 90 degree. Now let us see how many more equations can we make from this equation. Equation 1. Cosec square A minus 1 is equal to cot square A. Cosec square A minus cot square A is equal to 1. Third, cosec A is equal to root over 1 plus cot square A. And fourth, cot A is equal to root over cosec square A minus 1. We also know that cot A is equal to cos A by sin A and cosec A is equal to 1 by sin A. Now try to write this equation in terms of sin A and cos A yourself. By this we have completed our chapter Introduction to Trigonometry. In this chapter we have learned that in a right triangle ABC right angled at B, sin A is equal to perpendicular by hypotenuse, cos A is equal to base by hypotenuse and tan A is equal to perpendicular by base. Cosec A is equal to 1 by sin A, sec A is equal to 1 by cos A, tan A is equal to 1 by cot A, and tan A also equals to sin A by cos A. We also learned about the values of trigonometric ratios for angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. From the identities and ratios we also concluded that the value of sin A or cos A never exceeds 1, whereas the value of sec A or cosec A is always greater than 1. We also learned about trigonometric ratios of complementary angles, and also that an equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all angles involved. If you have any doubt in this video or in the chapter, please write it down in the comment section below. And that's all in this video. Please subscribe and stay tuned. I shall be uploading videos on chapters of mathematics class 10 NCERT. Till then, stay home, stay safe.